The Indian Stone Age is a remarkable 5 million-year blueprint of early human survival against a profoundly hostile planet. To understand this timeline, we define prehistory as the era before written language, a period where no script exists. This differentiates the Stone Age from the protohistoric period, defined by undeciphered scripts, and the historic era, where deciphered records begin. While global human activity begins approximately 3.3 million years ago, the archaeological record in the Indian subcontinent begins later, with evidence appearing between 500,000 and 2.5 million years ago. This Paleolithic period coincides precisely with the Pleistocene, a major geological epoch defined by extreme climatic shifts. During the Pleistocene, freezing conditions locked the higher altitudes in permanent ice. This created a landscape that was arid, cold, and biologically scarce. For early hominids, these conditions made high-altitude living impossible. Without reliable vegetation or shelter from the wind, these regions became biological dead zones. The quartzite men of India were environmental refugees. They were forced to migrate toward specific geographical pockets where the local climate allowed for a baseline of survival during the Ice Age. Because early humans could not yet construct shelters, their movements were entirely dictated by the natural topography of the subcontinent. Survival for these nomadic hunter-gatherers required three specific variables: a source of fresh water, a concentration of plants and animals, and accessible natural rock for protection and tool-making. This environmental pressure funneled early populations into specific river valleys. The Balin, the Sun, and the Narmada became the primary sites where these survival variables converged. The Narmada Valley, in particular, preserves the subcontinent's most significant evolutionary record. In 1982, archaeologist Arun Sanakia was working in the village of Hathnora when he made a discovery that changed our understanding of Indian prehistory. He uncovered the fossilized remains of Narmada man, dating back roughly 250,000 years. Narmada man belongs to the species Homo erectus. These ancestors had already developed the ability to stand upright, though they remained physically distinct from modern humans. Homo sapiens, the modern human species, would not appear in the Indian archaeological record until much later, during the Upper Paleolithic. The Narmada discovery confirms that India served as a continuous cradle for hominid evolution, hosting upright ancestors long before our own species arrived. Without agricultural knowledge, every aspect of the Lower Paleolithic life was defined entirely by the efficiency of the hunt. Hominids required tools capable of extreme durability. This led to the exclusive use of quartzite, a hard, metamorphic rock capable of withstanding heavy impact. They shaped this material by striking the raw stone to aggressively split it with a sudden, forceful blow. The large, heavy mass that remained is known as the core, while the sharp splinters that broke away are called flakes. This core technology produced the Paleolithic hand axe. It was an unpolished tool designed for blunt force utility rather than precise cutting. They also developed cleavers. While the hand axe was triangular and pointed, the cleaver was rectangular with a flat edge, used for hacking and heavy-duty butchery. These unpolished core tools represent a global technological standard. Archaeologists have excavated nearly identical quartzite tools in both Africa and Europe. This technological progression defines the Paleolithic timeline. The Lower Paleolithic focused on massive core tools. The Middle Paleolithic shifted towards smaller flakes, and the Upper Paleolithic brought a final refinement of these implements. Tool development in India followed a universal cognitive leap, mirroring the advancement of human engineering occurring across the Pleistocene world. In southern India, the archaeological evidence shifts from mere survival to proof of behavioral mastery. This is best seen in the Kurnool caves of Andhra Pradesh. Excavations at Kurnool revealed layers of concentrated ash embedded deep within the cave's stratigraphic record. This ash confirms that hominids in the Indian subcontinent had mastered the use of fire by the Middle Paleolithic. Further west, in Karnataka, the site of Hunasagi provides evidence of a different type of organization. Hunasagi is identified as a Paleolithic factory site. Unlike the alluvial plains of the north, the Deccan Plateau provided easily accessible stone. Hominids used this region as an industrial center, producing tools on a scale that suggests a centralized hub of manufacturing. These southern sites prove that hominids had begun to manipulate their environment through the mastery of fire and the centralized production of specialized tools. The most comprehensive record of the Indian Stone Age is Bhimbetka in Madhya Pradesh. Discovered by V.S. Wakankar in 1957, it remains the most significant archaeological site in the subcontinent. Bhimbetka was chosen for its unique geography. It offered raw quartzite for tools, dense forests for foraging, and reliable water sources within a single location. It also provided massive natural rock shelters, offering permanent protection from the Pleistocene climate. Because the location was so ideal, Bhimbetka contains an unbroken chain of human occupation across the lower, middle, and upper Paleolithic ages. In the upper Paleolithic, the evidence at Bhimbetka shifts from physical survival to cognitive expression. Using red ochre, early humans painted the daily fauna they observed. These figures record the Pleistocene animals sharing the landscape with the quartzite men. Bhimbetka proves that early humans in India developed a complex social continuity and the capacity for abstract thought while surviving the Ice Age. For hundreds of thousands of years, the Paleolithic was defined by brute force survival under the extreme conditions of the Pleistocene. Around 10,000 BCE, this era ended. The global climate warmed, the ice sheets receded, and the Pleistocene epoch reached its conclusion. The warming climate triggered an explosion of diverse plants and smaller, fast-moving animals across the subcontinent. The massive quartzite hand axes of the Paleolithic were useless against these smaller, faster targets. This environmental change ushered in the Mesolithic age and the development of the microlith, tiny, razor-sharp stone blades designed for high-velocity precision hunting. Abundant grasslands and a stable climate altered the human relationship with the wild. Instead of only hunting animals, humans began to manage and protect them. This behavioral shift led to the first domestication of animals, beginning with the dog, and set the human species on a new trajectory. This phase of domestication served as the critical bridge to the eventual agricultural revolution of the Neolithic age. The quartzite tools and ash layers found across the subcontinent serve as the physical data of human resilience. They are the hardware of an ancient engineering project, proving how early hominids successfully adapted to a frozen, hostile world.